joint distribution function. You have two variables. Okay, so they actually give you an example on it's called example 6.9. But actually there's an easier way to do this, and they're getting a little bit around it. You can use something called the Jacobian, and that's in section 6.9. It's not one of the sections that's, it's an optional section, but I recommend actually screenshotting those formulas. However you're putting those into the Brown Bombers, put that one into the Brown Bomber because it's useful. It's like it's a way to do the problem with as a formulaic thing. So they're kind of using that here without alluding to it, and then they move you to that other section. So in this one we have a nonlinear function. It's not just linear, just like number 4. And you have something easy looking for your probability function, the original one. So why I say it's easy looking, it's not a nonlinear thing. It's a linear thing on a square. So if you're going to do this for a joint PDF, at least I think the ones that you've been assigned on the homework, I could be wrong. So if we have time today, I'll look around and as you're working on it, if you want to tackle one of these, we'll see if we can get away with it, these steps. But you first fix y1 equals y1. You fix that one, and you consider only one variable, y2. So you do a 1D transformation. y2 is u divided by y1, and that's your H inverse of u. It's almost like you're going back to the one-dimensional thing. But that's not really what's going on. It's like, I don't think you guys will get that far in real analysis, but there's 2D versions of everything you're doing in real analysis. So the 6.9, section 6.9 is the actual 2D version as formulas. So the next step is to compute this f of y, but instead of like the usual chain rule, you have this absolute value of this guy. This absolute value is coming from this Jacobian method that's in 6.9. So here's the computations. Recall that y2 is u divided by y1. That's my H inverse. This was my f. You don't have to rewrite it again. I'm just rewriting it on the screen so you can see that all of it together. So my dH inverse du is, I'm holding the y1 fixed as if it were a constant in absolute value, so I get this. And if I multiply that times the original fy, I get this. And notice here I've substituted everywhere in for the y2 is u divided by y1. So y1 stays between 0 and 1 because it was held kind of fixed somewhere between 0 and y1. But the y2 is u divided by y1. So I have to replace that. And 0 elsewhere. And then you simplify that thing. And that's your PDF. So I think you should be able to do number 4 using this. Do you know?
What are the bounds? So we were saying that the absolute value of y over, 1 over y1. We were talking about absolute value, but when we put in the bounds, it's not absolute value.
Oh, that's only in the derivative. That's part of the formula right here. The absolute value is only on the derivative.
Okay. Only in derivative.
Right, and that comes from the Jacobian. You know, you guys took... It comes from the determinant of the minors. So you actually are taking a determinant when you do these things. It's just that they gave it to you in formulas. Do you remember when you guys did cross product in 205, 255, or vector calc? Do you remember the signs start switching? Right, so that's kind of where that's coming from. So in this problem, they go on to compute the expected value of u. So you just plug those, once you have the PDF, you can just plug those things into a formula, do the integration. So I recommend that you read on because that's the kind of thing, like if you look at the setup of the quiz, you have kind of your concept problems came first, then you had your straightforward calculation second, and then last you had something that might be a little bit harder to do. So that straightforward calculation would be, hey, here's a PDF, here's a transformation, here's a variable change, find the expected value. So they could ask things like that for the WPR. So I recommend that you go and look at this example thoroughly so you can see the other things that could be asked. I just didn't want to go, in here because it's already in your book. So actually it's not 6.9, it's 6.6. So section 6.6 is optional. They use Jacobians. You know what I might do is I might not do it in class, but I'll make a video of how to actually run through a problem with the Jacobians, because it's really straightforward, and it's like one formula that works for any type of joint probability function that you can think of. And so at least it has some conditions on it, but it's like if you want to memorize less things, that would be the one to memorize. So I think it's straightforward. But since it wasn't required, I don't want to force you guys to do it. I just think it's nice to, it's in the book already, you can use it.